Okay, let's look at it. A part 1, state Kirchhoff's first law. That's the junction law. And what's it the conservation of? Charge. And Kirchhoff's second law? Loop. And what is it the conservation of? Energy. Right, consider the circuit. Let's solve this circuit. Let us see. E minus 12 plus 3 minus 5i2. I'm looping outside, starting E going down. Yeah? No? So I have E minus 5i1 equals 9. Is that right? For equation 1? What's wrong, Dorian? I might have made a mistake. Well, what's the problem? One of my signs wrong? No. Right, what's the next loop we'll make? Oh, let's make a junction. I1 minus I2 minus 1.5 equals 0, yeah? So I1 minus I2 equals 1.5. Right, and one more junction, or one more loop, I mean. Yeah, I'm just saying left or right.
You can get I1 by itself.
If I go right, I'll get I1 by itself, yeah?
4 minus...
Well, I'm going to start with 12.
12 minus...
12 minus 4 minus 6i1 minus 3 equals 0. So this gives me the equation, so to speak, I1 equals...
12 minus 7 over 6, which is 5 over 6.
That's 12 minus 7, isn't it? 5
over 6, yeah.
5 over... minus 5 over 6? No.
Yes.
Yeah.
No.
5 over 6.
Yes. Over, yeah.
0.833?
Yeah.
So actually my third equation is the answer,
Then you just
for
minus 1.
which is actually part 1. And then if I sub that back in here, I can get part 2, which says it's...
I1 minus 1.5.
It's a negative then, huh?
Yeah.
Minus 0.667.
And then lastly,
EMF.
I can get the E by using the first one. So that's E equals 9 plus 5i1. And okay, so that's 9 plus 5 times 0.833. So what's the E there? What is it, Dorian?
5.67.
Now be nice to Diego. Okay, sorry, Diego, not Diego. Right. And lastly, they want the voltage between B and A.
Yeah.
So that would be, let's see, come on, part 2, V equals I or, which equals I1, which is 0.833 times, we have to include the, interesting.
No, you just plus it.
No, but they want the 4 volts too.
Yeah, so 4
Yeah,
plus-
well, let me just draw. So what we have here is a resistor and a voltmeter. Now let me just put 1 voltmeter here and then 1 voltmeter here. Okay, so V equals I or for the top one, huh?
which is
0.8
6. 0.8 times 3.
0.833 times 6, what's that?
5 over 6 times 6, so 5.
Oh, it's 5 volts.
Yeah.
Now, what way is the current flowing? This is interesting.
It's from B to A.
The current is flowing up here, right? So this one would say,
5 volts.
yeah, well, the way voltmeters work is it displays 5 volts, but that 5 means it consumed 5 volts. Now, what is happening here? The current is being forced backwards through the volt to the cell. So I think it would also say it consumed
4
4
volts.
volts. So if I put a voltmeter around both, I think it might say 9 volts. I think. But I would like one of you to check the answer before we go on to the last part, please. Could one of you check that?
Yeah, it says 9 volts.
It does? Okay. But if that battery was the right way, if that cell was the right way around, that is, if it was like this, because the current is going up, then that would be a -4.
Maybe 1 volt.
Yeah. Yeah. Okay. Can we continue
Yeah.
with the last part, which looks a bit interesting, doesn't it? Circuit. What's the V out? Now I'm going to redraw this one. It is a potential divider, but it's kind of drawn interestingly. So you have one resistor here when you combine the two. Then you have one resistor here when you combine the two. And then it is a potential divider where that's 12 volts and they're looking for the voltage here. Now we have to add these together. 1/5 plus 1/20, that's equal to 5/20, is it? So that means this one here has 4 ohms. And then for the other one, it's 1/8 plus 1/40. Right? 6/40? Yeah?
6 over 40.
Which is 40/6, which is 20/3. 20/3 ohms. Am I getting those two right? Add 5 and 20 and 8 and 40.
Yeah.
They're both right? So, we know the formula. V out equals R1 plus R2. R1 times Vn. That's the potential divider formula. 20/3.
Oh, okay.
Yeah, so what's this V out?
Is it 4.5?
Could be, it seems reasonable.
7?
Oh, 7.5.
4.5.
What is it, guys? Come on, just type it in on the calculator. It's 48/32/3, isn't it? 144/32. Don't make me do this without a calculator. What's that?
4.5.
4.5 volts. Okay.
That's what I said.
Oh, snap. Alright. Are we happy with 4.5? Yeah? Can I go to the next part?
Yeah.
Right, the next part is they want the power in the 20, isn't it?
I squared off.
But we don't know
You
it.
don't know.
V square over R.
Yeah.
What does the V? Do we say the R is?
No, we do know V.
Yeah.
It's V squared over R.
But is the R 20?
It's the 20, yeah. Now what's the V? So it has to be 12 minus 4.5. Yeah? Yeah. Yeah.
Why is 4 over 4 plus 20/3? Because we are looking for the V out, right? But the 4 is the
No, because.
I think the 4 is R1.
Yeah. Plus
And- And the 8 and the 40 is R2.
yeah, but we are looking for the V out and
Correct. And I hope I got this right. I thought the formula for V out was R1 over R1 plus R2 times Vn. I hope. Is that right?
Yeah.
Yeah. No, am I wrong?
No, no.
Is it R2 over R1 plus R2?
Yeah.
Really?
Shouldn't it
I
be
always
the
thought it
same?
was R1.
Me too.
This seems weird.
It's R2.
It's like somebody changed our history. And then we're like, what's going on? Because I really thought it was R1. I thought it...
He said it was R2.
Wait, in the marking scheme or my notes?
So Regina is right.
It's R2.
7.5 volts V out. So V out is R2 over R1 plus R2.
What?
But in the notes it is R2.
It is R2. So how can we all remember it as R1?
I think we might have
Since
done
yesterday.
some.
Yeah.
No, we might have done some questions where we did yesterday. We did R1 over R1 plus R2.
Yeah.
I think we did it like
We
that.
screwed it up yesterday.
Yeah. And, now we
And
all
this is
remember
what
it.
this is what we're remembering as the right formula.
Backfiring.
Classic. Classic. Well, thank you, Gina, for rescuing our memory. So, it should be R2.
Yeah, it is R2.
R2.
Mm.
So, Gina, what did you say it should be?
7.5.
Thank you, Gina. 7.5 volts. So that changes this here, doesn't it? Thank goodness I have some students awake. So is that 4.5 squared over 20? Because the two voltages have to add up to make 12 still, because 12 goes in.
Yeah.
So if 7.5 is on the out, then the other one must be 4.5, yeah? So what do we get for the power?
Oh,
1.01 watts. Yeah? Are you sure? Oh yeah, okay. And then lastly, what's the Q? It equals IT. Oh, rats, we need to work out the I, don't we? Rats.
Or you can just say V
Yeah.
over RT.
V-I-R.
V over RT.
V over R T. We know the V? We do. It's 4.5, isn't it? Yeah. 4.5 over 5 times 60. Right, what's that, son?
54 coulombs.
Okay, is that matching up with the marking scheme?
Yeah.
Marking scheme says 54?
yes.
Yeah. Okay. Well, don't worry. I think that potential divider formula is in the formula book, in the new one, anyways. What's wrong, Dorian? Or is that Gina?
That's me.
What's wrong?
Yeah.
No, I'm gonna skip all the electric questions for now.
You're going to skip the electric question? Ah, no, don't be doing that.
Oh, you know, here, see.
Oh, that's the last one.
That's the, no, I believe over here.
Yeah.
Yeah.
Oh, we need to do two questions for a second.
Yeah.